Now let's try to convert this Mealy machine to Mealy machine. This is a Mealy machine because output is associated with the states. Output is associated with this state. Okay. So what is the method? So method is always whenever a transition is going into some state, whatever is the output associated with that state, take it and write it there. Since the transition is going here and the output is 0, therefore I am going to write it as 0. And since the transition is going here and the output associated with this state is 0, I am going to write it as 0. And since the transition is like this, I am going to write it as 0. Transition is 1, I am going to write it as 1. Transition is 0, I am going to write it as 0. Transition is going here and the output is 0, therefore this is the Mealy machine. And if you have to see how to convert a transition table for the same diagram, the transition table of the Mealy machine to Mealy machine, then you can even look at it this way. Let us say A, B, C are the states and small a and small b are the inputs. Capital A on small a is going to B. Capital A on small b is going to A itself, and capital B on small a is going to B itself, and capital B on small b is going to C. Capital C on small a is going to capital B, and capital C on small b is going to capital A. And what are the outputs associated with the states? This is the delta function and this is the output function. So output associated is with A 0, with B 0, C 1. So what is this Mealy machine? Did you find it out? It is nothing but it is counting the all occurrences of AB. It is a DFA for ending with AB, and also it is counting all occurrences of AB. So this is this transition state table. Now let's convert this transition state table of the given Mealy machine to Mealy machine. So how to convert it is, go to every cell here B, and what is the output associated with B? It is 0. Therefore you associate it as 0, which means capital A on small a will go to capital B and output 0. Capital A on small a will go to capital B and output 0. See, I am not associating output with the state. No, I am associating output with the transition. See, these are the states and these are the transitions, right? So I am associating output with the transition. So if you look at this diagram, output is associated with the transition. It is, don't say that I am associating the output with the state. No, if I associate output with the state, that is Mealy machine, right? Now here it is going to capital A. What is output associated with capital A? 0. Therefore I am going to write it like this. Now what is the state output associated with B? It is 0. Therefore I am writing it as 0. What is the output associated with C? It is 1. Therefore I am writing it as 1. With B it is 0. Therefore 0. With A it is 0. Therefore it is 0. Got it? So therefore this is the Mealy machine for the given Mealy machine, and the Mealy machine is nothing but counting the number of occurrences of ABs. So you can delete these outputs, and these are the outputs now associated with the transition, and even remember the outputs here. So if the initial machine is counting number of ABs, now the final machine, the Mealy machine should also count number of ABs. Let's take an example, A, B, and trace it out. Capital A on small a is going to capital B, and what is the output? 0. And capital B on small b is going to capital C. Capital B on small b is going to capital C, and what is the output? It is 1. So if we check this, output is 0, 1, which is nothing but I got 1 corresponding to an AB. So it has counted AB. You can even take AB, AB. Capital A on small a, capital A on small a is going to capital B, and what is the output? It is 0. And capital B on small b is going to capital C, and what is the output? 1. And capital C on small a is going to capital B, and what is the output? 0. And capital B on small b is going to capital C. What is the output? 1. So I got 2 ones corresponding to 2 ABs. Got it? So this is the answer.